This is the first video of a series on simultaneous equations. We will be dealing with a system of equations which consists of two equations, each of which has two variables. That's two letters. We'll be using the letters x and y. First, one equation with two variables. So here, for example, is x plus y equals 4. So it's a single equation. It's got two variables, x and y. The solution to that equation is any pair of x and y values that fit the equation, such as if x is 1 and y is 3, 1 plus 3 equals 4. That is, it fits the equation, satisfies the equation. So that's a solution. X equals 1 and y equals 3. Here's a set of axes on a grid. There's the point 1, 3 plotted. That's that solution plotted. Here's another possible solution. X equals 2 and y equals 2 because 2 plus 2 equal 4. And there's that point plotted, the point 2, 2. Another solution, x equals 4 and y equals 0. Because 4 plus 0 equals 4, it satisfies the equation. Here's the point 4, 0 on the graph. So that's the point x4, y0. Another solution, x equals 6 and y equals -2. 6 plus -2 does equal 4. Here's 6, -2 plotted. X equals -3 and y equals 7. -3 plus 7 equals 4. There's -3, 7 plotted here. Even fractions, x equals 1.5, y equals 2.5. 1.5 plus 2.5 equals 4. And there is the point 1.5, 2.5. X equals -1.5 and y 5.5. They add to make 4. There's that point plotted. X equals 3 1/3, y equals 2/3. That works, they add to make 4. There's that point plotted there. X equals 4 3/4, y equals -3/4. They add to make 4. There's that point plotted. Now, what should be obvious is there's infinite solutions here, infinite pairs of x and y that will satisfy that equation, but it's clear they'll lie in a straight line. In fact, every point on the straight line here will fit the equation. So, infinite solutions when you've got a single equation with two variables. So, using this example, x plus y equals 4, I'm going to draw up a little table of x values. Work out the y values, plot the points, and then we'll see the line. So, if x plus y equals 4 and x was -2, that would require y to be 6. -2 plus 6 makes 4. There's that point plotted, -2, 6. When x is -1, y would need to be 5, so that -1 plus 5 equals 4. There's that point plotted, -1, 5. 0, 4. And there's 0, 4 plotted. 1, 3. And there's 1, 3 plotted. 2, 2. And there's 2, 2 plotted. 3, 1. And there's 3, 1 plotted. 4, 0. And there's 4, 0 plotted. 5, -1. And there's 5, -1 plotted. And finally, 6, -2, and there's 6, -2 plotted. So all these numbers, pairs of x and y, -2, 6, -1, 5, they all add together to make 4. So they satisfy the equation. The solutions there lie in a straight line, but there's infinite possibilities, the fractions and irrational numbers, every possibility, infinite possible pairs. So the solution is in fact that straight line. That straight line is labelled as having equation x plus y equals 4 because for every point in that line the x coordinate and the y coordinate add to make 4. Here they are in the table. It's a line because there's infinite points. So we don't need to have that -2, 6 plotted or -1, 5. But I'm going to leave 2 of them because we like to see where the graph, the line in this case, meets the x-axis and the y-axis, where it crosses the axes. Because if we were sketching this line without a grid like that, we like to see these positions, 0, 4 on the y-axis and 4, 0 on the x-axis in this case. So where the line meets the axes would be labelled. However, we're going to be using a grid when we do the simultaneous equations. So the 2 key points are, in fact, and the only important points are 2 of them, because they're really easy to get, and that's the 2 particular values that's enough to draw the line. If we have the point 0, 4, there it is on the y-axis, and the point 4, 0, there it is on the x-axis, so that's where the line meets the y-axis and where it meets the x-axis. 2 points are enough to draw the line. We don't need all these points, we just need 2. And the 2 best points to take are where the line meets the axes, because we like to know them anyway, and they're easy to get. It's easy to make x 0 and work out y, and make y 0 and work out x. So these are the key points, 0, 4 and 4, 0. 2 points are needed to draw a line. That's enough to sketch the line x plus y equals 4. The line is the solution to this equation, x plus y equals 4. So the line is the solution to the equation, because the equation has infinite solutions. You can't write them down, but you can show a diagram. You have to remember also this line is infinite. It goes to infinity in both directions, up to the left and down to the right. It goes on forever. So that's the solution to one equation with 2 variables, a line. So it's called a linear equation because the graph's a line. So that's a linear equation. So that's it in summary. An equation in 2 variables has a solution of an infinite set of points which lie in a line. So solution to this equation is that diagram. That diagram shows the solution. Now here's a second example. 2x plus y equals 8. If I want the solution to that equation, it's going to be a line. You basically draw the line. 2x plus y equals 8. I'm going to rearrange this equation. It's rearranged to y equals 8 minus 2x because it's easier to work out the y values now. All you do is you take the x value, substitute it in here, and it works out y. 8 minus 2 times negative 2. That's 8 minus negative 4. That's 12. Next one, it's 8 minus 2 times negative 1. Well, that's 8 minus negative 2. Same as 8 plus 2, so it's 10. 8 minus 2 times 0, well, that's 8. 8 minus 2 times 1, well, that's 8 minus 2 is 6. 8 minus 2 times 2, 8 minus 2 times 3, 8 minus 2 times 4, 8 minus 2 times 5, 8 minus 2 times 6. So, notice they go down in 2s in that pattern. So, here we go. Negative 212, there it is. Negative 110, there it is. 0, 8, 1, 6, 2, 4, 3, 2, 4, 0, 5, negative 2, and 6, negative 4 are all plotted. They do indeed lie in a straight line. This is a linear equation. The graph will be a straight line. The solution is, however, all possible points on that line. So that black line is the solution. Key points, and all that's necessary to draw that line are where it meets the axes. So 2 positions, and we don't really need the rest. We need 0, 8 on the y-axis when x is 0, y is 8. It's easy to work out, putting x to be 0 in. Even up here in the first equation, without that rearrangement, if you make x 0, you can see that y is going to come out as 8. And if you make y 0, you can see that 2x is 8, so x is 4. So it's possible to quickly work out the two positions where the line meets the axes. So looking at this first equation, if you make x 0, that term disappears and y is 8. If you make here the y to be 0, the y disappears and 2x is 8, so x is 4. So it's quite quick to work out where the line meets the axes. x0, y8, y0, x4. And that gives these two positions. So that's the solution to the equation 2x plus y equals 8. It's this line, which happens to meet the axes at 0, 8 for the y-axis and 4, 0 for the x-axis. And again, if you're sketching that without the grid, that's how it would look. So that's how we would sketch the line. We need to show the point 0, 8 and 4, 0. However, we're going to be using the grid in this piece of work. So what we've got is two lines, two equations. The x plus y equals 4, the first one we looked at, and 2x plus y equals 8, that second one we looked at. And if we were asked to solve this system of equations, so now there's two equations and two variables. It's got x plus y equals 4, and it's got 2x plus y equals 8, and the solution to that is a value of x and y, so a pair of values, x and y, that fit both equations. So they fit the first equation, that is they add together to make 4, and they fit this second equation, that is double the x add the y, it makes 8. So it's to solve this pair of equations. When you solved x plus y equals 4, the solution was this line. So that's the solution to the first equation, x plus y equals 4. That's its solution, that line. That line is the solution to the second equation, 2x plus y equals 8. So if there's to be a solution to the system of equations, it must be on the first line, x plus y equals 4, but it also must be on the second line, 2x plus y equals 8. So to be a solution to this equation, the x and y values have to fit both equations. The x and y values have to be in both lines. Well, there's only one point which will be in both lines, and it's where the two lines cross here at 4, 0. That is the only point that is on both lines. There's only one solution to this equation, and it's the point of intersection, 4, 0. So that's the solution, the point of intersection, 4, 0. Solve this system of equations, and the solution is x equals 4, y equals 0, because it fits both equations. Here we check on it. Putting it into the first equation, x plus y equals 4, we use x4, y 0, 4 plus 0 equals 4. That works fine. Second equation, 2x plus y equals 8, make x 4 and y 0. It's 2 4s add 0, well that makes 8. So 4, 0 satisfies both equations. It's the solution to the system of equations. So this is a system of equations. It's simultaneous equations because we're taking them together. So simultaneous equations. So what we had was a system of linear equations. These are linear equations because their graphs align. It's a system because they're taken together. But we'll refer to them as simultaneous equations, and we've solved them using this graph. So this is said to be the graphical solution. So this is solving simultaneous equations, and this is the graphical solution because we've drawn the graphs. And the point of intersection is the solution. So that is what this video is about. Simultaneous equations, two equations with two variables, the graphical solution, draw the graphs, find the point of intersection. So that's it in short. Draw the two lines. The point of intersection is the solution. To draw the line you need 2 points. Points to get are where the line meets the axes. So what you do is you make x0, that's where it crosses the y-axis, and you make y0, that's where it crosses the x-axis. You plot the 2 points and you carefully draw in the line. So here's an example. I've retained the line 2x plus y equals 8, but here's another line, 2x plus 3y equals 12. So I want to solve this. Instead of drawing up a table of x and y values, I just need where x is 0 and where y is 0. So the one we've done earlier was 2x plus y equals 8. If x is 0, then you work out y. So I'm going to use a cover up here. If I make x 0, the x term there disappears, and it gives me y is 8. So just be covering over the 2x, because x is 0, 2 nothings are nothing, y equals 8. And that's what we get here for the first one. So that was x is 0, y is 8. What about when y is 0? I'll cover over the y, it's become 0. 2x is 8, well x is 4. So for that one, we've got x is 4. So I can plot 0, 8 and 4, 0. There they are. That's a line 2x plus y equals 8. So that's the one we just did. All we needed to do it was make x 0, work out y, make y 0 and work out x. You can do it mentally. Y is 8 when x is 0. X is 4 when y is 0. And just be careful to plot them the correct way around. 0, 8 means 0 along and 8 up. It's very easy to put these the wrong way around and put the 8 on the x-axis by mistake, so that's something to be careful of. If we do this for the next one, so it says 2x plus 3y equals 12. What about when x is 0? Well, cover up the x. That's gone to 0. So now 3y is 12. 3y is 12. Well, that means y is 4. So x 0, y 4. What about when y is 0? Make y 0, so that disappears. 2x is 12, so x is 6. So there it is, x 0, y is 4, because 3y is 12 there. Y 0, 2x is 12, so x is 6. And now you've got to be careful to plot these the correct way around. It's 0, 4. So there's 0, 4. And it's 6, 0. There's 6, 0. That line is a line 2x plus 3y equals 12. And that's it, pretty much done, because you can look at the graph. Look where they're crossing. They're crossing at 3, 2. So the solution is x3, y2. There it is there. Solution, x equals 3, y equals 2. It's just the point of intersection 3, 2 here in the graph. Now, that's it done, but you can check it. If you want to do a check, just take the first equation here is 2x plus 3y equals 12. So 2x plus 3y is 12. Make x3, y2 the solution. Does it work? 2 3's are 6, 3 2's are 6, and they add to make 12. So it works. And the other one was 2x plus y equals 8. So make x3 and y2. 2 3's add 2. Does that make 8? It does. So it fits both equations fine. That's the solution. X equals 3 and y equals 2. Sometimes it's given as the coordinates 3, 2. Here I'm just saying x equals 3 and y equals 2. So that's it done. It's draw the graphs, find the point of intersection. Hard bit obviously is drawing the graphs. So here's a second example. And I'm going to use the same procedure. I'm going to simply draw up a little table with x being 0 and y being 0. So there's the line 2x plus y equals 4, and there's the other line 2x minus 3y equals 12. So what we do is we cover up the x-axis becomes 0, y is 4. So here it is, x0, y is 4. Make the y 0, 2x is 4, so x is 2. Now all you do is you plot 0, 4 and 2, 0. Draw the line through these 2 points. Be careful to keep the line on target and not let it go off course. So that's the line 2x plus y equals 4. Now we do it for the other line, 2x minus 3y equals 12. So make x 0, negative 3y is 12. So y is negative 4. So you've got to be careful with cases with minus signs. So that's x becomes 0, it disappears, it's got negative sign in front of the 3y. And now if we make y 0, that disappears. Just to make it clear, that takes care of the minus sign as well. There we go. So it gets rid of the negative 3y there. 2x is 12, so x is 6. So again, that was x0, negative 3y is 12, y is negative 4. y0, that disappears. 2x is 12, x is 6. Now, plot the point 0, negative 4, there is a way down here. And the point 6, 0, there it is there, 6, 0. Draw the line through carefully. There it is, going through 0, negative 4 and 6, 0. Point of intersection here is 3, negative 2. Solution, x equals 3, y equals negative 2. So just reading off this point of intersection. That's the solution to the system of equations. You do the check. So there's the 2x minus 3y equals 12, and we've got x3, y negative 2, so it's 2 times negative 3, minus 3 times negative 2, that's 6 minus negative 6, same as 6 plus 6, 12. Works fine. Next one was 2x plus y equals 4, there's x3, y negative 2, that's 6, add negative 2, well that does give you 4. So it works fine. So you can check the solution by substituting back into the original equations and making sure it works for both equations. So that's the graphical solution. You draw the two lines, you find where they intersect, and that's the x and y values for the solution. If you click the link in the description, there is a worksheet which gives you some you can practice on. We'll also have the answers. The answers will be in the form of the graphs showing the point of intersection and therefore the solution. So they're simply printed off from a piece of software that does that work. So there are 12 questions, 12 solutions. Click the link in the description and you'll also get access to the notes on all the videos on simultaneous equations. What I've just covered is drawing a straight line using lots of points, then drawing it just with 2 points, making x0 and y0, and then that's the graphical solution, the one we've just covered. So that's if you click the link in the description. The next video will be on algebraic solutions, the substitution method. So the notes covers everything. Hope you found this video useful. Thank you.